Good morning, chemistry students. Today we are continuing our discussion on solutions. We're actually looking at how to dilute concentrated solutions. So that is specifically what we're looking at today. It kind of ties in with standard A and B for our current unit. So jumping kind of straight in. What do I mean when I'm talking about diluting a solution? So, any of you who might have younger siblings at home might have seen parents do this with like juices. When you give a baby a juice, you don't want to give them the full concentrated juice. Like, I wouldn't want to just go to the refrigerator, grab some apple juice, and give it to an infant. It's going to upset their stomach. It's too sweet for them. Too much stuff at one time. So what most parents do is they dilute it. They dilute it by adding water to it. Well, that same idea is something that we actually do quite frequently in chemistry in a laboratory setting. So what is dilution? Well, dilution is just the process of decreasing the concentration of a solution. So we typically will say stock solution. The reason it's called stock solution is because it is something that is in the chemical stock room. But another way of thinking of it is as a concentrated solution. So anything that's a concentrated solution can be considered a stock solution. So all we got to do is we got to add more solvent to it. If we're talking about typical substances, that solute, bad misrains, that solvent being added is probably going to be water. 90% of the stuff that you will play with in first year chem, and even maybe first year college chem, is things that are made with water. Now, water's not the only solvent. We could make a solution that has an alcohol in it and diluting it by adding more of an alcohol. Hexene is something that is used in an industrial setting as an industrial solvent, but for our purposes, we're talking about water. So when we're looking at a concentrated solution, especially something that is a colored solution, you're going to notice that your concentrated or your stock solution is going to have a very, very dark color, where your diluted solution is going to have a light color. And that's a good visual illustration of how many particles there are in that particular solution. In my stock solution or my concentrated solution, we've got a lot of particles shoved in with not as much water. In the diluted solution, we've got a boatload of water or a boatload of solvent with very little solute. Now, a stock solution, as I said, is a concentrated solution that you end up being diluted. So typically, I already said that, it's water's your universal solution. The more water you add, the more diluted your solution's going to get. So thinking about like apple juice, if I'm diluting it, I'm going to eventually get to a point where I'm not going to be able to taste the apple juice anymore if I add too much water. Think about it. If I take a gallon of water and I add like a half a cup of apple juice, I'm not going to be able to really taste that apple juice because it's a lot of solvent with a little bit of that concentrated solution. So it's very, very, very diluted. Now, just kind of a reminder, we mentioned this earlier when we were talking about solutions, that when you're in a laboratory setting and you're trying to label your solution, you have to make certain that you include the molarity as well as the solvent used. Most of the time, again, it's probably going to be water, but you also need to make certain you have the molarity of the solute that is in that solution. So how do we actually do dilutions in a laboratory setting? Well, depending on how how specific I want to get, or how I can't think of the word I wanted to use. Anyhow, I have several different pieces of equipment that we can actually use. Most of the time, what you see in a laboratory setting is you see chemists using what is called a volumetric flask. So a volumetric flask is a flask that has one line on its neck. And at that line, you have a specific volume of liquid. So let's say my little volumetric flask is 100 milliliters. If I get something up to that line and exactly at that line, I have 100 milliliters exactly of that solution. Well, when we're going to dilute, we not only use that volumetric flask, but we also use other things to measure out a specific amount of my stock solution. So you have to have a specified volume of your concentrated solution. Now, how do you get that specified volume? Well, it just kind of depends on, what equipment you have handy. You can use graduated cylinders to measure out that specific volume. That is something that we would typically use in a first year chemistry class. You could use syringes. We don't have those. Pipettes. We actually do have some pipettes that have specific volumes on them. I'm going to say they can measure specifically like milliliters, I believe, tenth of milliliters, down to that specific. Or what most likely you would use in like a college setting or AP Chem setting is a burette. So a burette is just more precise than a graduated cylinder. It's a really, really long, skinny tube of glass, and it's got a lot of ticks that are spread out over that volume. So it's really easy to see that you have a specific volume of your concentrated solution that you're adding. So what you do is you're like, okay, I know I need 12 milliliters of concentrated hydrochloric acid. So I use either my graduated cylinder or I use my burette to put 12 milliliters of hydrochloric acid into that volumetric flask. Then you put the volumetric flask with your solvent, and you add solvent to that volumetric flask until the solvent reaches the line on the neck. Once it reaches the line on that neck, well, you could calculate the molarity. You could determine the molarity of that new solution. Now, if you're not doing an experiment right away with your diluted solution, then of course, make certain you label it. Never walk away from a substance in a lab setting without having it labeled. That label needs to include the molarity as well as the solvent used. Now, remember I said it depends on how specific we want to use B to determine the amount, which would determine the equipment I'm using. Well, if, first year chem, high school chem, we're not as worried about if we are as precise as possible. So what you might see in a high school laboratory setting is you just quite literally do the entire dilution in a graduated cylinder. So you put in the graduated cylinder, your initial concentrated solution, that initial volume that you wanted, and then you just keep adding your solvent until you get up to that desired volume. Graduated cylinders are not as precise as a volumetric flask, so you're not going to have the exact concentration that you think you have, but for what we do in high school chem, it's sufficient enough. So, dilutions, if you can't figure out already, involve calculations. You're going to have to determine, hey, how much concentrated solution do I need? Or, hey, what's the molarity of this diluted solution now that I've added the water to it? So we have our dilution equation. The equation is M1V1 equals M2V2. I prefer that one, but I think our textbook uses MIVI, MFVF. So I for initial, V final, F for final. Same idea here. Ones are my initials, twos are my finals. So what do I mean by initial? Well, initial is anything that's concentrated. So my M1 is the molarity of my concentrated or my stock solution. My V1 is the volume of that concentrated solution. Your M2 is the molarity of the diluted solution. V2 is the volume of that diluted solution. If I give you any three of these variables, you should be able to solve for the fourth. The nice thing with this is because of the way the equation is written, what you're going to end up doing is you divide by the thing that you don't want. So let's say I am trying to solve this equation for volume 1. So I need to know what volume of my concentrated solution that I'm going to have to measure out in order to get a specific diluted solution. So I need to know V1. That means I got to get M1 beside it, away from it. Well, to move M1 to the other side, we divide both sides by M1, which means V1 equals M2, V2, wow, bad misreigns, divided by M1. So I'd plug and chug. Same idea, even if I'm trying to find a diluted solution. So let's say that I have measured it out. I know my final volume and I know my initial things, but I don't know the final molarity. So I'm going to have to actually calculate that final molarity. So, dang it, I didn't want green again. Sorry. So I'm trying to find M2. We know the other three variables. Well, to find M2, we get M2 by itself. That means I divide both sides by V2. So M2, my final molarity, would equal M1 V1 over V2. I prefer to rearrange the equation and actually write that rearranged equation before I start plugging numbers in. That is my preference. That's how I'm going to have to set them up. I have seen some students over the years who prefer to plug the numbers in and then rearrange. I don't care. You'll get to the same path. You get to the same place, taking two different paths. But you got to show the calculation. You got to show where the numbers are going and what's being multiplied and what's being divided. And if we don't remember already, every number needs a unit. So units haven't went away completely. I know we didn't see them with pH with our lab, but we have to have units with our dilution stuff. The reason we need to have our units is because we've got to make certain everything is in the same unit. So for volume, it really doesn't matter. Am I measuring my volume in liters or am I measuring my volume in milliliters? It does matter if they're not the same. So if I'm telling you that, hey, I want 2 liters of solution and I'm starting with 3 milliliters, those two volumes are not in the same unit. You got to get them in the same unit. So of course, remember that 1 liter equals 1,000 milliliters. You might have to do conversions. Also, you might be asked to determine the amount of water that you're going to end up adding. So I mean, in a real setting, you're just going to keep adding water until you get to your desired volume. But in a calculation piece, we might just say, okay, well, how much water am I adding to this concentrated solution to get it there? Well, the volume of solvent added is equal to V2 minus V1. So I do believe that that little piece right there is not on your formula sheet. So that might need to be something that you add to your formula sheet. So let's look at a couple example problems. How do we use this equation? So first example, I've got a stock solution that is 1 molar sodium chloride. How many milliliters are needed to make a 100 milliliter of a 0.75 molar solution? So you got to figure out what are your 1s and what are your 2s. What's your concentrated things? What's your diluted things? Good news is most of the time they tend to be close together verbally in the problem. So notice how these two numbers are close together. They're either both my 1s or both my 2s. So my M, my molarity, is going to be either my M1 or my M2. I do need to read a little bit more specific to figure out which one it is. And usually you're going to see words like concentrated solution, diluted solution, or in this particular case, stock solution. So it's telling me that that is my stock solution, which means by default it must be my M1. Okay? Well, it's asking me how many milliliters of that solution do we need? Well, that's my V1. My V1, I don't know. That kind of looks like a 2, so let's V1. So those other two numbers are my 2s. It's my M2 and my V2. So M1 V1 equals M2 V2. Oh, I didn't do that. Sorry. M1 V1, M2 V2. So again, I tend to prefer to rearrange the equation. It is asking us for volume of stock solution. That means I need that by itself. So I divide both sides. M2 V2 divided by M1. So I can now just plug and chug. I know that I have to put 0.750 on top because it's the final, and I know that I have to put 100 milliliters on top, and these two things are being multiplied together. Remember, Miss Raines doesn't like using multiplication symbols. I prefer using parentheses. Doesn't matter, really and truly. So on the bottom, I got to put my M1, which is 1.0 molar. My units will let me know for sure that I got it set up correct. Notice, M divided by M. My M's cancel and we're left with just milliliters. Well, milliliters measure volume. So when I plug this into the calculator, whatever the calculator tells me is my right answer. So handy dandy calculator is going to tell me 75. Probably going to just say 75. But my honor students need to remember that significant figures. Fewest number of significant figures was 3, so I got to have 75.0 to make sure we round appropriately and have the right number of digits. So notice, yes, you can just plug the numbers in and then rearrange and solve for V1. That is another valid way to do the problem. Do whichever one makes the most sense to you. But either way, I got to see the numbers written down so I know exactly what you typed into the calculator. All right, example number 2. This is a two-part problem. So we have a concentrated solution of hydrochloric acid that is 12 molar. It's asking us for the volume in liters of hydrochloric acid needed to make 2 liters of a 1 molar solution. M1, V1, M2, V2. So we got to figure out who are my 1s and who are my 2s. I would prefer if you listed them out. I'm not going to insist that you do. You could just label them in there. Since this has the word concentrated, I know that that has to be my M1, which means that my other M has to be my M2. Since 2 liters is really, really close to that M2, that means it's probably my V2, which means we are trying to solve for V1 again. So V1 equals, rearrange my equation, I divide by the stuff that I don't need to get it on the bottom. I rearrange the equation and then I plug in chug. So M2 has to be on top. V2 has to be on top. M1's going to be on bottom. Handy dandy calculator. Oh, bad, Miss Raines. That's not the right unit. There we go. Handy dandy calculator would give me a number, but I can see my units. M divided by M gives me liters. So yes, my calculator would end up giving me my unit in liters. So handy dandy calculator, 0.17 liters of hydrochloric acid. So I need 0.17 liters of that concentrated solution. Now, how much water am I going to end up adding to that concentrated solution to make that diluted solution? Well, to figure that out, my volume needed equals my V2 minus my V1. So volume of water needed, volume of solute needed, however you want to think of it, it's still V2 minus V1. So I'm going to take my 2 liters and I'm going to subtract from it 0.17 liters. And handy dandy calculator is going to tell me that I get 1.83 liters of water would need to be added. So if I was using a graduated cylinder instead of a volumetric flask, I could take my 0.12, bad Miss Raines, 0.17 liters and pour it in the container. And then I could go and get another graduated cylinder and measure out 1.83 liters of water, pour it in the container. And I would have 2 liters of Bad Miss Rain's 1 molar solution. Okay. So, example number 3. Oh, yeah, I forgot that I did this. So, example number 3, it's asking us what is the final concentration. I don't know why I'm circling the word concentration. What is my final concentration? Final concentration, that is my M2. It is asking me to find M2. If 55 milliliters, well, we know that's a volume, of water is added to 5 milliliters of a 6 molar solution. Ignore the typo. SOLUTION. Wow. That's really, really bad. So notice my 5.0, my 6.0 are geographically close to each other in the problem. That means they're both going to have the same subscripts. Well, the other things, my 2, that means these have to be my 1. So my M1 is at 6 molar. My V1 is 5 milliliters. And I forgot that it all pops up at the same time, but that's fine. So in order to use our equation, M1V1, M2V2, I need to know the final volume of the solution. It's not telling me the final volume. It's telling me that I've got 5 milliliters and I'm adding 55 milliliters to it. Well, I'm not trying to find the volume of water needed to be added. I'm now finding out how much these are together. So if I don't tell you that it's the final volume, if I'm saying, hey, we're adding this amount of water, then yes, you're going to need to add those 2 numbers together to get your V2. So that V2 is not 55 milliliters. My V2 is 60 milliliters because the final volume is going to include the concentrated solution plus the water. So now we can plug and chug and actually solve for our M2. M2 is what we need, so we're going to get M2 by itself. I don't remember where it shows up, so it might end up being covered up in a second, but M2 equals M1 V1 divided by V2. All right, plug and chug now that we've got everything in the right units, right numbers. So M1 V1, 6 molar times 5 milliliters divided by V2, 60 milliliters. I can check my units. Milliliters cancels out. We were left with molarity. Molarity is what we want. So, handy dandy calculator. Oh, it is going to cover it up. So, 6 times 5 divided by 60 gives me 0.5 is what your calculator is going to say. Honors students, got to remember your significant figure rules. So 2 digits is the smallest number of significant figures, so my answer should have 2 significant figures. Hence why we put 0.50. So general, again, remember, y'all don't stress the sig figs. All right. So one last problem. You guys pause your video, give it a try. There we go. So example number 4. Sorry, I had to fix it so that all of it was viewable and not some of it was hidden under my little circle. Whew. All right. You need 1.5 liters of 0.75 molar sodium nitrate solution. We have a known solution that is 5.5 molar. It's asking us for how many milliliters of sodium nitrate would we need to use? Okay, this one didn't use the words concentrated or diluted, so let's look at our M's. My stock solution is going to have a higher molarity. That means 5.50 is my M1. It is my initial molarity. So that means it is asking us for V1. So my other two values are my V2 and my M2. Not rearrange my equation. Let's write my equation. M1 V1, M2 V2. All right, it's asking me for V1. So V1, to get it, I divide both sides of the equation by the thing I don't want over there anymore, which would be M1. All right, let's plug and chug. V1 equals 0.750 molar times 1.50 liters divided by 5.50 molar. All right, molarity cancels. We're left with liters. Liters is a measurement of volume. So handy dandy calculator. 0.75 times 1.5 divided by 5.5 gives me my V1 is 0.20. Says 4 or 5 on the calculator. I'm going to round to 3 significant figures, so 0.205 liters. All right. Did we answer the question, though? Question asked for it in milliliters. I could have converted my V2 to milliliters, and I would already have it in milliliters. So yes, I could have converted this 1.5 liters to milliliters and then plugged and chugged. I would end up in the same place if doing it at the end. So I'm going to do it at the end because that's the way I did my problem. So let's come over here and find it in milliliters. So 0.25, bad misread, 0.205 liters. 1 liter is 1,000 milliliters. So that gives me 205 milliliters. So how many milliliters of water needs to be added to get my desired volume? Be careful here. I don't want to just subtract from the V1 that I'm giving you on the screen because that V1 is in the wrong unit. I cannot subtract straight from that 1.5 liters. I have to have them in the same unit. So might have been better to convert it at the beginning because either way I'm going to have to need that number in milliliters. So V2 minus V1, 1,500 milliliters minus 205 milliliters gives me that we need to add 1,295 milliliters of water to get 1.5 liters. So one way to solve the problem. I'm 99.99% certain when I actually typed this PowerPoint up, I did it a slightly different way. So I'm going to erase that for a second just so I can see the way I did it when I typed it up. Oh, no, I actually did it the exact same way. So, two different ways to get to the same place. That is it for today. You have some dilution problems in Google Classroom. Make certain you are showing your calculations. At a minimum, you must show me what you are typing into your calculator with units. I encourage students that are struggling with math, that math is not necessarily their best thing. Go ahead and write down your givens. Write down what is known in the problem so that when you plug and chug, it makes it a little bit easier. Write down your equation rearranged. It makes it a little bit easier. They're not required for the practice to get the full credit, but they're great strategies to use to help stay organized when you're doing calculations. That is it for today. As always, if you need me, I should have my open office open. If not, shoot me an email or send me a message in Google Classroom. That is all for today. I'll see y'all next time I see you.